Wow. All right, so I've checked out JTolan Media1's latest video where he's supposedly testing gravity. I'm not too sure why he calls it a gravity test. It looks pretty much like a curvature test. Anyway, have a look at the comments where everyone is pretty much on their knees, cock in mouth. You know, amazing stuff, brother. This is a real scientist. Great job, brother. This is science from no fanfare. There's that guy, Robert D, down here. I didn't understand it. Well done, Robert. Honesty. What else is there? Perfect experiment. Great video. Globetards are brainwashed beyond belief. Guarantee you that none of these people in this comment section could explain what JTolan did. Right, so here is his contraption. He's got an inclinometer strapped to his telescope and then pointed his telescope at a distant mountain at varying distances from 54 miles out to 55 miles and measured the change in the angle via the inclinometer. He really didn't need to make such a shitty contraption. We actually already have precision instruments that can do this. Theodolites, auto levels, total stations, those sort of things. The thing is, though, that most flat earthers say that these cannot be used over long distances. But why? Well, there are three reasons. Number one, Earth curvature. Number two, refraction, which we'll sort of ignore for the moment. And number three, optical resolution, or Rayleigh's criterion, or diffraction limit, as some people call it. All right, so here is a top-of-the-line total station. And you'll see that the telescope part has a resolving power of 3 arc seconds. And that is basically a direct result of the aperture size, plugging that into Rayleigh's criterion or the diffraction limit formula. And the reason why they usually are limited to shorter distances is because after about 200 meters distance, the error in eye level due to Earth curvature overtakes the uncertainty due to the resolution of the eyepiece. So you can see here at 200 meters there is about 3 millimeters of drop on the Earth curve calculator, and the angular resolution according to the Rayleigh's criterion is about 3 millimeters as well. But as you get further distance, say up to 1,000 meters, then you've got about 80 millimeters of drop, and your uncertainty due to the resolution is only about 14 millimeters. So that is why they tend to limit these things over a few hundred meters. It's also why Rayleigh's criterion is utterly insignificant when it comes to the curve calculators. So using Mount Canigou as an example, it's an observation over 263 kilometers. And if you use that with a P900 at full optical zoom, the uncertainty due to Rayleigh's criterion or the diffraction limit is only about 4 meters. But 2,500 meters of the mountain is hidden. So back to JTolan, he could have just used a theodolite or an auto level or a total station to measure the precise angle to the mountain. So here's my spreadsheet from a few videos ago. All it basically does is calculate the viewing angle above or below eye level to a certain mountain or building or whatever, both on a flat earth and on a globe. On a flat earth, the math is pretty easy. We've got a pretty simple right angle triangle. So the mountain that he is looking at is approximately 54 miles away. It's 482 meters above his current elevation. So you've got your right angle triangle, do the simple trig, and to see that mountain from his observer location, he should be pointing his telescope up 0.318 degrees. The globe math is a little bit more complicated, but it works out to be he actually should be pointing his telescope slightly down 0.017 degrees on a globe. Right, so the measurement that he actually gets from his observer location up to the mountain is 0.195 degrees. And that is absolutely nowhere near the flat earth prediction and nowhere near the globe prediction. So straight up, that says his contraption is very shit and very poorly aligned. And he kind of acknowledges that towards the end of the video. So that's fine. But his thesis here is in this graph that the globe prediction should show a changing angle, like the green line there, and his measurements show basically a flat line and therefore flat Earth. All right, there are two major problems with that. The first one is that his graph is kind of upside down. As you get further away from an object, the angle towards it, especially on a globe, should get lower. So instead of this green line going up, the green line should go down. Secondly, where is the flat Earth prediction? So yes, the prediction on a globe is that the angle should change as you get further away, but that is also true on a flat Earth. As the object is further away, your viewing angle to it gets lower. So let's have a look and we'll compare the flat Earth prediction to JTolan's measurements. So what I've done here is reproduce each of his 6 stations, the distance to the mountain that he's looking at, again using pretty simple trigonometry, what the viewing angle should be. Again, his measurements are way off. So all I've done here in between this, this predicted angle and the adjusted angle is literally just shift them down so that it somewhat matches. All right, so here are his measurements on the right, and I have plotted the adjusted angle and the measured angle on this graph down here. And as you can see, it is shit. His contraption is shit, his measurements are shit, and they match neither the globe nor the flat Earth.